S. Chan presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Hello everyone. So limit concept, if we talk about, it's anyhow seems to be very simple that we are taking limit and we are reaching to a point, but sometimes the problem becomes very difficult when you see something and you are not approaching, but there is a possibility, and we call such problems indeterminate forms, and for such forms we use L'Hopital rule, or we call it L'Hopital rule. So such forms we'll be learning, we'll be understanding in this lecture. Hello everyone, I am Dr. Seema Thakran. If you want to know the concept in detail, please refer to the book by S. Chan Publishing. The e-book link is given in the description box below. So in this part 1, we'll understand and we'll learn indeterminate forms and L'Hopital rule, how to calculate such forms which seems difficult, but there is a possibility to have that limit, and we use L'Hopital in such situations. So let's start with indeterminate forms and L'Hopital rule. So indeterminate forms. What are the forms? First we'll discuss what are those forms. So the forms are, and the concept is related to limit. This is all about limit. We always talk about limit of a function. So we'll be given a function, but the function has the tendency that the limit is not seems to be infinite, but when we use the L'Hopital rule, there you will see that there is a possibility to get that limit. So indeterminate forms are in limit concept, and there are forms like infinity by infinity. It means you will get such a form when you are substituting the point in the function, your function is taking the form of infinity by infinity, or you say 0 by 0, infinity minus infinity, 0 to the power 0, or 1 to the power infinity, infinity to the power 0. These are the forms we call indeterminate forms. I'll just take up example to make you understand that how we get such forms in limit concept. So very basic example, and the example is, suppose I want to know the limit of the function sin x by x. You just check the limit is, anyhow when you are substituting, you are approaching x tending to 0, sin 0 is 0 and x is 0. So this is 0 by 0 form, and it now because we don't know, if you don't know the concept of L'Hopital, you cannot calculate it. So let's start and let's understand how we calculate such limits, such indeterminate forms of limits. What you do, this is 0 by 0 form. So whenever you are getting 0 by 0 form or like any form, then first thing is we use L'Hopital, or I'll call it L'Hopital, the correct pronunciation is L'Hopital rule, and this rule says you differentiate numerator and denominator separately with respect to the respective variable, because you are calculating the limit with respect to x. So you have to differentiate both with respect to x, others will be treated as constant. Sin x derivative is cos x with respect to x, x derivative is 1, and limit is as it is. Cos 0 is, now you can see problem is resolved and we have limit answer, because now there is no problem. Cos 0 is 1 and denominator is 1. So the limit is 1 finally, and if sin x by x, in the beginning it was 0 by 0, there was no answer for the limit. Now we have an answer and it is by L'Hopital rule. Next, second problem I am taking. So these are the forms we calculate by L'Hopital rule. My next example is limit x tending to 0, 1 minus e to the power x upon x. Again, if you substitute 0, what exactly you are getting? 1 minus e to the power 0 is 1. So, 1 minus 1 and finally it is 0 by 0. If it is again 0 by 0, the same way apply L'Hopital rule. So, using or applying and you can see that these becomes the formulas. Whenever you see limit extending to 0 sin x by x, we learn it because we have calculated it. In future, it is not every time you will calculate, you can learn, it becomes a formula. This is also another formula and you see what limit it is. So, 0 by 0, differentiate numerator, I just write also what exactly the rule is. Differentiate numerator and denominator separately. With respect to the variable, and this variable is to which you are taking the limit. So, when you separately differentiate, one derivative is 0, e to the power x derivative is e to the power x derivative is 1, limit is same. In any case, limit will not change because you have to differentiate with you have to take limit extending to 0. So, this you are not changing, but you are changing the concept and the function by L'Hopital rule. So, now when you are substituting the limit, what exactly the expression is? So, you can see it is e to the power 0 and finally it is minus 1. So, this is basically the formula. If I just say, so this is minus 1, direct you can learn, this becomes a formula now. Many a times we use it directly, that this limit is minus 1, and if I change it, there is another formula also. So, if I just change it, and very useful formulas these are. If I just change it, now you can see this is formula is for minus and 1 plus e to the power x, this is 1 plus e to the power 0 upon 0. So, this is finally 2 by 0. It means this limit is infinity, and if you do it by L'Hopital, this is not that indeterminate form. It seems, because when you do this question now, when you do this question, you think that this is almost the same question, but be careful. This is 2 by 0, it is not matching with the forms which I have written in the beginning. There is no form, this form, it means this limit is basically infinity, and infinite limit we say limit does not exist. Whenever the answer of the limit comes infinity, we always say that this limit does not exist. Limit answer should be finite. Limit does not exist. And so, this is indeterminate forms. 3 examples we have taken, and you can see the calculation also. So, it means when we are applying indeterminate forms, we have to be careful that the form should be of 0 by 0, infinity by infinity, and infinity by infinity. In the beginning I have written the forms. In this example, there is no chance, there is no possibility, because when you sometimes you do it, and I just show you what wrong thing you do. If you apply here, the wrong part is, if you apply the L'Hopital rule, it becomes 0, the like the way you did in this question, and e to the power x derivative e to the power x derivative is 1, and when you are just substituting e to the power 0, the answer is coming out to be 1. It means if you are not clear with the concept, the limit answer will come out to be 1, which is wrong. It is not correct. The correct answer is that this limit is infinite, because this is 2 by 0 and ultimately it is infinity. So, you have to be careful when you are using L'Hopital rule. The same way, now limit extending to 0 cos x, be careful, this is 1. These are the standard formulas, and the formulas are coming by L'Hopital rule. Why I have not written in the denominator x? Because there is no need. Limit extending to 0 cos 0 is 1. We know cos 0 is 1. But for 10x, we have this formula again. And these are the standard formulas by, and there is another formula which I have already solved, and that is sin x by x is 1. So these are the formulas you can say, or you can say that all by similar pattern by L'Hopital. You have the limit, and anyhow the limit seems to be like not existing, but it is existing, and you can see the standard formulas. So in part 2 of this lecture, I will be taking little like different or difficult problems, but the problem will be solved by L'Hopital. These are the standard formulas we have calculated by L'Hopital rule, and in part 2 we will be completing, or in part 1 like we have taken standard formulas. In part 2 also we will be taking the standard formulas which are very helpful, but little you can say the level is little difficult. If you want to know the concept in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. Please like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.